All right, this is the next lesson in Algebra 2, Unit 6. This is Lesson 3. It's called Logarithmic Form and Exponential Form, and evaluating logarithmic expressions. So recall that an exponential equation. Recall that an exponential equation is an equation containing one or more expressions that has a variable as an exponent. Now, a logarithm is a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. Think of a logarithm as an exponent, okay? So what we have here is we have something in exponential form, b to the x power equals a, and this here is this equation written in logarithmic form, okay? Okay, so this number, or this letter, or this variable, whatever this is, in this case it's a b, shows up down there, okay? The exponent, in this case x, goes over there, and the a value here shows up there, okay? And again, b has to be greater than 0, and b cannot be equal to 1. We talked about that in the first two lessons, okay? But this is exponential form, and this is logarithmic form, okay? And over here it says, this equation right here, you read that as saying the log base b of a is x. Okay, that's how you read that. Log base b of a is x. Or log base b of a equals x. Notice that the log is the exponent. Now the first two examples, if this page didn't make much sense, don't worry. It will when we go through the first two examples. Okay? So here we go. Example 1. Take all of these equations, which are in exponential form, and write them in logarithmic form. Okay? So here's how we do that. Log, this number 2, that's your base. So it should be a little smaller. It's not in line with log. It's like a subscript. And then you put 32. That's called the argument. Equals 5. My Chromebook's about to die. Let me plug it in. Okay, so like I was saying before, I took this equation, which was in exponential form, and I rewrote that in logarithmic form. Okay, so again, this 2 is like your subscript. It's not in line with the log. See how log is up a little bit? 2 is a little below that. Okay, and the 32, that's called your argument. Okay, the next one. Log base 4 of 16 equals 2. Again, notice how the 4 is like a little lower than the rest. Next one, log base 8 of 512 equals 3. So again, the number after the equal sign is the exponent in all of these, okay? Now this next one I'm going to write 2 different ways. I'm going to say, if you want to write log base 10 of 1 over 100 equals -2, that's fine. But the better way to write this one, so I'll put or, is to write it like this. Okay? So, bottom line, if there's no base, it's implied to be a 10, okay? Logarithms are based off of powers of 10. So if you don't see a base, if you don't see a subscript, then it's implied to be a 10. So if I was answering this question, I would write it the bottom way. If you read any math books in your spare time, you'll see them written like this. Okay, so if there's no number there, it's implied to be a 10. So if I had to answer this question, I would write it the bottom way. It's not wrong if you write it this way, but it's like It's like doing square roots. If there's no index, it's implied to be a 2. If there's no exponents on variables, it's implied to be a 1 normally. So if there's no number there, it's implied to be a 10. Okay, so that was example 1, taking equations in exponential form and writing them in logarithmic form. Example 2 is going the other way. Take the equations, which are all in logarithmic form, and write them in exponential form. So this 2, that's your base. The 4 is the exponent. And it equals the argument 16. Okay. The next one, 9 squared equals 81. Remember, the number after the equal to symbol is your exponent. 3 to the 5th power equals 243. 36 to the 1/2 power. Remember we did rational exponents before? Equals 6. And this last one, there's no base, so it's implied to be a 10, remember. So 10 squared equals 100. Now this next definition goes with what I talked about earlier. A logarithm with a base 10 is called a common logarithm. That's what it's called. If no base is written for a logarithm, the base is assumed to be a 10. We talked about that in the previous page. Okay, now we are going to evaluate logarithms. I have 10 examples in this lesson. Those are the first 2 examples, and the next 8 are faster. Okay, we're going to evaluate logarithms. So here are the steps. Step 1, convert to exponential form. Step 2, write each side of the equation with the same base. Step 3, set the exponents equal to each other and solve. Okay, so those are the 3 steps we're going to follow. Sometimes you can do these in your head. So sometimes you don't have to go through all 3 steps. If you know the answer right away, that's fine. So here we go. Example 3, evaluate log base 5 of 125. That means what power, 5 to what power equals 125. So some of these you may be able to do in your head. The first 2 you can probably do in your head. But I'm going to follow the 3 steps above. Step 1, convert to exponential form. So I'm going to say 5 to the x power, because we don't know what it's equal to, equals 125. Step 2, write each side of the equation with the same base. I can rewrite 125 with the base of 5, because 125 is 5 cubed. So 5 to the x power equals 5 cubed, which means x equals 3. So that is my answer. My answer is 3. Since there was no x in the original problem, I'm not going to circle x equals 3. I'm just going to circle a box in 3, because there was no x. Okay. Here you go, example 4. Evaluate log base 2 of 64. If you know the answer right away to this one, that's fine. But I'm going to write it in exponential form. 2 to the x power equals 64. Now I'll write each side with the same base of 2. 2 to the x power equals 2 to the 6th power, because 2 to the 6th power is 64. So that's my answer. But really what I'm doing is I'm saying x equals 6 because the bases are the same. They're both 2. So therefore, my answer is 6. Okay. Example 5, evaluate log base 3 of 1 over 243. So this is saying 3 to what power equals 1 over 243. So think back to the previous unit. Let's say I have x to the negative, let's call it m power. That is the same as 1 over x to the mth power. So we're basically going to apply that to this problem. Because 1 over 243 can be thought of as 3 to the negative 5th power. Let me write that a little neater. It looks a little messy. Hold on. There we go. Okay. Think about it like this. 3 to the 5th power equals 243. So 3 to the negative 5th power equals 1 over 243. Okay. So now we have the bases are the same, set the exponents equal. X equals negative 5, which is my answer. Same thing for example 6. 7 to the x power equals 1 over 49. You can think of 1 over 49 as being 7 to the negative 2 power. Because 7 squared is 49. So 7 to the negative 2 power is 1 over 7 squared, which is 1 over 49. So therefore, x equals negative 2. So negative 2 is the answer when I evaluate that logarithm. Okay, last page. These are going to be trickier, though. So these you probably cannot do in your head, okay? I think the examples 3, 4, 5, and 6 you can probably do in your head. 7, 8, 9, and 10 I don't think you can, okay? 7, let's first write it in exponential form. So for these problems, you definitely have to follow the 3 steps I gave you on the last page. 3, 4, 5, and 6, you get away without following those steps. But 7, 8, 9, and 10, you really have to follow those steps. Now what I'm going to do is I'm going to rewrite each side with the same base. Now, there's no secret to finding that out. You just have to think about that yourself. Is there a number that I can write 8 and 32 of that has the same base? Think about it like this. I can rewrite 8 as 2 cubed. And I can rewrite 32 as 2 to the 5th power. So I took each side of the equation and I wrote it with a base of 2. Now think back to the last unit. Whenever you have a power raised to a power, you multiply the exponents. So this is really 2 to the 3x power equals 2 to the 5th power. And now you set the exponents equal and you solve. So 3x equals 5, which means x equals 5/3. So that's my answer to that one, 5/3. That was a little tricky. Same thing for example 8. Let's write it in exponential form first. 9 to the x power equals 27. And then let's try to write each side with the same base. You can write each side with the base of 3. There's no secrets to getting that. You have to figure that out on your own. 9 is the same as 3 squared. And 27 is the same as 3 cubed. Power to a power, multiply the exponents. 3 to the 2x power equals 3 to the 3rd power, like that. Now, since each side has the same base, you can set the exponents equal and solve for x. 2x equals 3. X equals 3/2. So that is the answer. Okay, 2 more. Write it in exponential form first. 1/4 to the x power equals 2. Let's write each side with the same base. I'm going to use a base of 2. 1/4 can be thought of as 2 to the negative 2 power. Okay? Because 2 squared is 4, so 2 to the negative 2 power is 1/4. And I just put 2 to the first power on the right. Power to a power, multiply. 2 to the negative 2x power equals 2 to the first power. The bases are the same, so set the exponents equal to each other and solve. Negative 2x equals 1. X equals negative 1/2. So again, there's no x in the original problem, so I'm not going to circle that. I'll just circle the negative 1/2. And one more to end it. Exponential form first. Let's write each side with the same base. I'm going to use a base of 5. If 5 squared is 25, then 5 to the negative 2 power is 1/25. And 5 to the 5th power is 3,125. Power to a power, multiply the exponents. 5 to the negative 2x power equals 5 to the 5th power. Each side has the same base, so set the exponents equal to each other and solve for x. X equals negative 5/2. All right, so that's the end of that lesson. Okay, there was a lot in that lesson. First we converted between logarithmic form and exponential form, and then we evaluated logarithmic expressions.